In this video, we're going to talk about how to test a hypothesis about a proportion. So we're going to start by looking at an example. It says recently 20% of a certain model of car have needed costly transmission work before reaching 100,000 miles. The car manufacturer has redesigned one of the transmission's components and hopes that this has solved the problem. In a random sample of 100 cars, 14 of them needed transmission work. So the question is, has the company solved the problem? Well, if the company has solved the problem, then that means the percentage of cars that need transmission work should be less than 20%. And so we want to see if our sample data supports that conclusion. So my null hypothesis here is that the proportion is still equal to 20%, or as a decimal, 0.20. And my alternative hypothesis, my hope, is that the proportion is less than 20%. So we're going to use Minitab here to calculate the p-value. And our alpha for number 1 is 10%, which means confidence level of 90%. So open up Minitab. I'm going to go to one sample, and we're still using the same TZ and proportion, so this is a proportion problem. I need to change to summarize data. Now, my number of events is going to be the 14 cars in my sample out of 100 that still needed the transmission work. So number of events and number of trials comes from sample data. Then I check the perform hypothesis test box. My hypothesized proportion from the hypothesis that I wrote is 20%. So that's going to be 0.20. Then I need to go over to options. My alternative hypothesis in this case is a less than hypothesis because I'm saying my alternative hypothesis is that the proportion is less than 20%. My confidence level is 90. And my method is changed to normal approximation. We made that change as well when we did the confidence intervals, and I need to do that again here. So change from exact to normal approximation. Then I click OK, and this is what comes up. So I have my information that I entered here, N is 100, 14 in the event. Normal approximation is used for this analysis. I should see that. I should see my null and alternative hypotheses. These should match what I wrote, which they do. And then I see the z-value and the p-value. And I know when you're doing the homework, they break it down into steps, so they want you to enter the z-value and enter the p-value. So my p-value here is 0.0668. So if I compare that to the 10%, this is 6.68%, that's less than alpha. And so if p is less than alpha, so that means I reject the null hypothesis. This is the same rules that we saw for hypothesis testing about means. And if I reject the null hypothesis, that means that there's evidence for the alternative hypothesis. So there is evidence that the proportion is less than 20%. Or that the fix worked. Now, if I look at an alpha level of 0.05, should I reject or not reject the null hypothesis? Now, if I look at my p-value, p is equal to 0.0668. That's not less than 0.05. So for this alpha level, I cannot reject the null hypothesis. So since p is greater than 0.05, I cannot reject the null hypothesis. So I can't conclude that the company has solved the problem, or I don't have enough evidence to say that the company has solved the problem. So you can think of alpha levels as the smaller the alpha, the more strict you're being about the amount of evidence that I need. Because nothing in problems 1 and 2 changed except for the alpha level. But if I decrease the alpha level, then my p-value needs to be smaller in order to be able to reject the null hypothesis. So this p-value here of 0.06 is small enough to reject the null hypothesis for alpha equals 0.10 or for 90% confidence, but it's not small enough to reject the null hypothesis if alpha is 0.05 or 95% confidence. So smaller levels of alpha means you need a smaller p-value in order to be able to reject the null. So lastly, we're going to talk about the different possibilities that you have in terms of making a correct decision or making an error. And keep in mind that we're using sample data here to base our decisions on. So there's always a possibility that your sample data, you're going to just happen to get a weird sample, and it's going to cause you to make a wrong decision. So the 4 possibilities that can happen. Number 1 is that you can reject the null hypothesis when the alternative hypothesis is what is actually true. So your sample data here led you to make the correct decision. Possibility 2 is that you do not reject the null hypothesis when the null hypothesis is true, and this means that your sample data also led you to make the correct decision. You can make an incorrect decision if you reject the null hypothesis, but the null hypothesis is what is actually true. That's what's called a type 1 error. You can also make an incorrect decision if you do not reject the null hypothesis, but you should have rejected the null hypothesis because the alternative hypothesis is what is actually true. And that's called a type 2 error. So this chart on the next page basically just lays out that information. This is reality. Either the null hypothesis is true or the alternative hypothesis is true. If the alternative hypothesis is true and you do not reject the null, that's an error. If the null hypothesis is true and you do reject the null, that's an error. Or you can have the correct conclusion if the null hypothesis is true and you do not reject it, or if the alternative hypothesis is true and you do reject the null hypothesis. And again, going back to the different values for alpha, they depend on the consequences of making a type 1 error. So if the consequences of making a mistake are severe, so this would be a situation that's like life and death, like medical research, they are going to use very small levels of alpha, 0.01 or maybe even smaller, because they don't want to make a mistake. You don't want to give people a drug that has, nasty side effects and you have a lot of people dying. That's going to be a problem. If the consequences of making a mistake in your research are not life or death, if you're doing maybe sociological research, something like that, educational research where, nobody's going to die if your statistics are incorrect, then you can use a higher level of significance like alpha equals 0.05 or 0.10.